Hello everybody, welcome into another lesson. So today we are going to get into the determinant of a square matrix. Now to evaluate the determinant of a matrix, it must be a square matrix, which means it has the same number of rows as it does columns. So let's actually start with a 1 by 1 matrix. So let's say I have matrix B that just has 1 in it. So it's abbreviated det B, and it looks like the absolute value of B, but it's really not the absolute value. But of course, you're going to change it into what would look like the absolute value of 1, but it's really not the absolute value. It just would equal 1. It just, for a 1 by 1, it equals what's inside the matrix. Of course, the determinant is the numerical value associated with the matrix, the total numerical value of it. Now, if I have matrix C, which has just -4, it's a 1 by 1 with the entry -4, that determinant would look like the absolute value of -4, but it's not the absolute value, really. You would get -4 because it's just a 1 by 1. You're just literally going to get the value of what's inside the matrix. 1 by 1s are easy enough. It's just what's inside the matrix. Now, what we're going to be working with today is a 2 by 2. So you have matrix A that has arbitrary constants A, B, C, and D. You're still going to get one numerical value for this determinant. It's the overall numerical value of it. To find the determinant, you're going to take what looks like big absolute value notation of this matrix. Instead of the brackets, you'll have what looks like a big absolute value sign for the whole matrix. You'll have A, B, C, and D inside of that. And then what you're going to do is you'll take A times D minus B times C. That is the value of a 2 by 2 matrix. So let's do some examples here. We'll do determinants of 3 by 3 matrices in the next two lessons, because when you get to 3 by 3 and higher, there's two ways to do it, which we'll do a separate lesson on each method, but today's just a 2 by 2. So let's see, we have matrix A, which has entries -4, 2, 5, and -2. So we're going to evaluate the determinant of this matrix. So, of course, what you want to do then is to evaluate the determinant of A, you're going to want to place all these numbers inside of what looks like a big absolute value sign. Just take all the numbers from the matrix and do that. Now, what we're going to do here, remember the determinant of a 2 by 2 is your A, D minus B times C, okay? Well, picture each of these entries, A, B, C, and D. So we're taking AD, A times D, which would be equal to -4 times -2 minus 2 times 5. So now we just got order of operations. This would turn into 8 minus 10, which would be -2. So the determinant of this matrix would in fact be -2. Alright, next one. Matrix A is a 2 by 2 matrix with entries 8, 0, -1, and 3. So let's evaluate the determinant of A. So we'll just place all these numbers inside of what looks like a big absolute value sign. So once again, it's going to be your A times D, which would be 8 times 3, minus your B times C, which would be minus 0 times -1. Well, the 0, -1 turned to 0, so really you just have 8 times 3, which is 24. So the determinant of this matrix is going to be 24. Now, there are many applications for determinants. We'll get into the applications thereof. You can actually use determinants to solve for areas of triangles. You can use it to test for collinear points. You can even use them to solve systems of equations, and then you can use them to determine if a matrix has an inverse or not. Those are all things we're going to use here in the future. Alright, so you have matrix A, this time another 2 by 2. Entries 9, 3, -2, and 1. Okay. So we got this matrix here, A, has entries 9, 3, -2, and 1. So let's evaluate the determinant of matrix A. We'll just put all these entries in what looks like a big absolute value sign. So just take them and do that. Alright, so now you're going to take that 9 times 1. So 9 times 1 minus 3 times -2. Well, 9 times 1, of course, is 9. Minus 3 times -2 turns into plus 6. So the determinant of this matrix would in fact be 15. So yeah, determinants actually of a 2 by 2 matrix at least aren't that bad to find. Okay, next one. That's a -7. I was making sure I got the sign right. Alright, so matrix A has entries -7, 11, -7, and 2. So let's find the determinant of this matrix. Of course, take all your entries, put it inside of a big absolute value looking sign. So now take your AD numbers, which would be -7 times 2 minus 11 times -7. So -7 times 2 is -14. -11 times -7 would turn into positive 77, which would end up giving you the value of the determinant to be 63. That's the value of the determinant, would be 63. All right. All right, so let's do the determinant of this matrix with entries 4, 0, -3, and 4. So let's set this up here. You're going to take, of course, your 4 times, well, wait, let's transpose these into a big absolute value sign first. I'm jumping ahead. Okay, so take 4 times 4 minus that 0 times -3. Well, 0 times -3 goes to 0, so all we have to deal with is 4 times 4. That will give you 16. So the determinant of this matrix would in fact be 16. I only got 4 more, then we're done. Short lesson today with this one. Alright, so matrix A has entries 1, 8, 5, and 9. So let's go ahead and evaluate the determinant of this matrix. So place all these entries inside a big absolute value looking sign. Now, take your 1 times 9 minus your 8 times 5. So 1 times 9, of course, is 9. Minus 8 times 5, that'd be minus 40, which should give you a determinant value of negative 31. So the determinant of this matrix would be negative 31. Three more. Alright, so here's matrix A with entries negative 6, 5, negative 3, and 9. Let's evaluate the determinant of this matrix. So, of course, take everything, put it inside of a large absolute value looking sign. Now, we're going to take that negative 6 times 9 minus 5 times negative 3. Whoops, there we go. It's positive 9 for the 9. Okay. So now, negative 6 times 9 is negative 54. Negative 5 times negative 3 turns into positive 15. So you have negative 54 plus 15, which should give you the value of the determinant to be negative 39. So the determinant of this matrix would be negative 39. I only got 2 more. 2 by 2s are incredibly easy. Alright. Whoops, I'm jumping ahead of myself again. Yes, it's true, we're going to take the determinant, but let's lay the stage first. Alright, so matrix A has entries 0, negative 3, 8, and 10. So let's take the determinant of this matrix, which we'll just take everything, put it inside of a big absolute value looking sign. Whoops. Alright, so now take that 0 times 10 minus that negative 3 times 8. Well, 0 times 10 is 0. Negative 3 is positive 3 times 8. That'd be positive 24. So the value of this determinant would be 24. You end up getting 24 as the value of this determinant. And I think we only got 1 more, yes. So let's see, we got 12, 2, negative 5, and 8. So we have matrix A with values 12, 2, negative 5, and 8. So let's go ahead and evaluate the determinant. Alright, so let's see, take everything, place it inside of a large absolute value sign. A looking sign, I should say. I don't want to say it is the absolute value because it's not. Alright, take that 12 times 8 minus that 2 times the negative 5. So let's see, 12 times 8 is 96. Negative 2 times negative 5, that turns into plus 10. So 96 plus 10 is 106. So the determinant of matrix A would end up being 106. So that's it for this lesson. Next lesson we're going to start part 1 of determinants of a 3 by 3 matrix, which is it's a little more work. It's not hard, it's just a little more work. When you get into 3 by 3 and higher matrices, there's two methods for evaluating the determinant. We'll go into the normal method for the next lesson. The lesson after that, we'll do a method called expansion of cofactors. So I hope everyone has a great day. Take care.